Look at those iconic images: men walking on the moon, the space shuttle soaring high, our International Space Station, a beautiful blue Earth below, but often something is absent. Where are the glittering stars? The background is just black. This question pops up often. It's a perfectly natural one. We all look up at night, we see a sky sprinkled with stars. So, why don't they appear in these incredible space photos? It makes you pause and think, what is really going on? Many famous pictures show this. The lunar landings, for instance. Astronauts stand on gray dust. The American flag is planted. Yet, the sky is an inky void. No friendly constellations shine. It's the same for many ISS shots. Just darkness behind the bright station. This isn't a new question. It has puzzled people for decades. Ever since we first ventured beyond Earth's protective atmosphere. It leads to curiosity naturally, and sometimes to suspicion. But the answer is not hidden. It's all about light and science. When stars are missing, minds wander. Some begin to speculate. They wonder if it's a secret. Perhaps something is being concealed. Are governments hiding alien life? Or are the photos themselves altered? These sorts of questions arise, especially in online discussions. Conspiracy theories can sound exciting. The idea of a grand deception, that the moon landings were faked, or that UFOs are airbrushed out. These stories grab attention. They prey on our doubts, and a lack of easy answers. It's human nature to question, but before we jump to conclusions, it is important to seek facts. Science offers a clear explanation, one grounded in how light works, and how cameras capture images. It's actually quite straightforward. No need for complex cover-ups, just a little understanding. The truth is often more fascinating than any fabricated tale. It reveals the universe's nature, and the limits of our technology, and even our own perception. So let's explore the real reasons why those stars play hide and seek in so many pictures from space. Our eyes are amazing instruments. So are modern digital cameras. Both work by capturing light. Light bounces off objects. It enters the lens, or your pupil. Then it hits a sensor, or retina. This creates the image we see. It's a beautiful, complex process. A key concept here is exposure. This is how much light is allowed in, and for how long. If it's very bright, you need less light. So the camera's shutter is fast. Your pupils will also constrict. This prevents the image being washed out. Everything looks clear and sharp. Now imagine a very dim scene, like a room with one candle. To see anything, you need more light. The camera's shutter stays open longer. This is called a long exposure. Your pupils will dilate wide, trying to gather every faint ray. This helps you see in the dark. Contrast is also vital. This is the difference between light and dark. If you have something very bright next to something very dim, it's hard for a camera or eyes to capture both at once. One will likely be overexposed, or the other underexposed. Think about taking a selfie on a very sunny day. The sun is blazing behind you. What happens to the photo? You might look like a silhouette, or the sky is completely white. The camera struggles with the brightness. It can't capture you and the sun perfectly. This is because of dynamic range. That's the range of light intensity, from the darkest darks to brightest brights, that a camera can record simultaneously. Our eyes are pretty good at this. Better than many cameras, in fact, but even they have limits. Especially with extreme differences. Imagine you are at a concert. The stage is brilliantly lit. The performers are bathed in spotlights. Can you see the person beside you clearly? And the bright stage lights perfectly? And the faint exit sign at the back? Probably not all at once. Your eyes adjust to the main focus. The same principle applies everywhere. If a camera is set to capture a very bright subject properly, like an astronaut in a white suit or the sunlit surface of the moon, then faint objects in the background, like distant dim stars, will simply not show up. Here on Earth, seeing stars is easy, especially on a clear night, and away from those bright city lights. You just look up and there they are. Thousands of twinkling pinpricks scattered across the vast dark canvas. It's honestly a common, beautiful experience and one that connects us to the cosmos. Several factors make this possible. Firstly, nighttime brings darkness, since the sun is illuminating the other side of our planet. Thankfully, this deep darkness allows faint starlight to travel across unimaginable distances and eventually, finally reach our eyes without being overpowered by sunlight. Our atmosphere also plays a role. It might seem counterintuitive because, yeah, it can cause light pollution and make stars twinkle, but it also scatters sunlight. During the day, this is what makes the sky blue. At night it means the sky itself isn't a source of overwhelming light, and critically, our eyes adapt. When you step out into the dark, it takes time for your vision to adjust. Your pupils dilate, as we mentioned, and chemical changes happen in your retinas. You actually become more sensitive to faint light. This dark adaptation is key for seeing those distant, dim stars. Now let's journey into space. Imagine you are an astronaut, floating outside the space station or maybe standing on the moon's surface. The sun is an unfiltered blaze. There's no atmosphere to scatter it, or to dim its intense power. It is incredibly, fiercely bright. The Earth itself, seen from orbit, is also, honestly, incredibly luminous. Sunlight reflects off its surface, off clouds, oceans, and land. It's like a giant glowing jewel. The moon, too, is very bright when the sun shines upon it. Its dusty surface reflects strongly, so when a camera takes a photo of an astronaut in a white spacesuit against the backdrop of the moon, or with the bright Earth nearby, the camera settings have to be adjusted for these very bright objects. The shutter speed will be very fast, and the aperture will be small. These settings are perfect for capturing the astronaut, the spacecraft, or Earth. But they are completely wrong for capturing faint, distant starlight. The stars are still there, of course, billions of them, shining away, but their light is just too feeble compared to the immediate dazzling subjects. So, can astronauts see stars in space? Absolutely, yes they can. It's a common misconception that they can't, but it really depends on the conditions. If an astronaut is in Earth's shadow, or looking away from the sun, and allows their eyes to dark adapt, the stars will appear, clear and brilliant. Many astronauts have described this. The view of the Milky Way, unfiltered by any atmosphere, is apparently breathtaking. The stars don't twinkle in space because there's no air to disturb light. They are steady, sharp points, a truly magnificent sight. Specialist space telescopes like Hubble or the James Webb Space Telescope are designed to see these faint objects. They can take very long exposures, sometimes for hours or even days, pointing at one tiny patch of sky, gathering every precious photon to reveal galaxies billions of light years away. So it's not that stars aren't there or that they can't be seen. It's about the specific conditions and the settings of the camera or the adaptation of human eyes. Most photos are taken of bright things, and the stars simply get lost in the glare of nearby brilliance. The missing stars in space photos are not a sign of a conspiracy. There's no grand cover-up at play. The explanation lies in basic physics and the way cameras operate. It's about exposure and contrast, about bright subjects outshining faint ones. Simple science when you break it down. You can even try this yourself. Go out on a clear night, find a bright street lamp, and try to take a photo of it with your phone or camera. And also capture the faint stars nearby. You'll likely find it very tricky. The lamp will be clear, and the stars invisible. This doesn't mean stars vanished or that your camera is faulty. It just means the settings prioritize the brightest object in the frame. The same thing happens with astronauts, the moon, or the sunlit Earth. The science is consistent from your back garden to outer space. Science helps us understand perspective. It shows how what we see depends so much on how we look, and the tools that we use. The universe is full of wonders. Some are bright and obvious, others require careful observation and a willingness to learn. Keep looking up, and keep asking why.